Welcome to another episode of my reviewer series for civil engineering topics focusing on geotechnical engineering problems. For this episode's situation, the figure shows the soil layers in a tube 100 mm by 100 mm in cross-section. Water is supplied to maintain a constant head difference of H across the sample. Hydraulic conductivities of each soil are listed below, and all measurements in the figure are given in millimeters. Having the following parameters and coefficients, we are to determine the following. 1. The equivalent hydraulic conductivity of the system in the direction of flow. And 2. The rate of flow in the soil if the value of the constant head is 1.2 meters. When it comes to stratified soils na nakaka-experience ng fluid flow, dahil nga varying yung hydraulic conductivity ng bawat soil or yung tinatawag din na coefficients of permeability, need muna natin i-compute yung overall equivalent value para ma-simplify ang pag-compute sa rate of flow. And given this figure, along the direction ng flow ng water natin is merong both parallel and perpendicular layers. To start with this, una muna natin consider yung mga layers na merong alignment. For this case, ang hahanapan muna natin ng equivalent coefficient ay layers B, C, and D. Since ang positioning ng layers nila ay parallel to the direction of flow, ang gagamitin nating formula to solve for their equivalent hydraulic conductivity is as shown in the screen. K sub H is equal to the summation of the soil layer heights multiplied by their individual hydraulic conductivity values divided by the total height of the soil layers combined. Para dun sa height na i-consider natin, lagi nyo lang tatandaan na pag ang analysis is parallel, ang consider nating measurement ng soil is yung perpendicular sa flow na dimension. And vice versa, pag ang analysis naman natin is perpendicular, ang i-consider natin na height measurement is yung parallel naman sa flow na dimension. Plugging in our given values sa formula, starting with summation of H times K, we'll have 20 times 0.0025 for layer B, plus 30 times 0.00625 for layer C, plus 50 times 0.004 for layer D. Then, divide it by the total H, which is just 20 plus 30 plus 50. This gives us a value of 0.004375 meters per second. And as you can see, we can now consider this as a single type of soil para masolve na natin siya along with the other layers na perpendicular naman sa flow. And to solve that, ibang formula naman gagamitin natin, which is equivalent coefficient K sub V is equal to the summation of heights of the soil layers divided by the summation of quotients of each heights and their individual hydraulic conductivity values. Now, just a quick tip. Personally, mas madali kong maalala yung mga formula na involved dito pag nakasulat siya in this manner. For flow parallel layers, total height times equivalent coefficient is equal to the summation of individual heights times their individual coefficients, or simply, H sub T, or total height, times K sub H is equal to the summation of H times K. For perpendicular layers naman, the total height divided by the equivalent coefficient is equal to the summation of individual heights divided by their own coefficients. Notably, mas madali talaga itong maalala kasi yung parallel flow is ginamitan lang ng multiplication, while yung perpendicular naman is just division. But of course, depende pa rin naman yan guys sa diskarte nyo kung paano nyo siya i-memorize. Nagkataan lang din na kanina kasi, mas prefer ko yung pinaplug na lang yung value sa formula, kaya nakaderive na agad yung pagkuha sa mga equivalent key values. Going back, let's insert our values for solving the perpendicular flow. So, along sa direction ng flow, ang total height natin is 150 plus 200 plus 100. And for the summation of quotients, layer A natin has H equal to 150 millimeters divided by 0.005 plus layer BC din natin, which has 200 millimeters divided by 0.004375 plus layer E, which has 100 divided by 0.002. This gives us an equivalent hydraulic conductivity value of approximately 0.0036 meters per second. With that, pwede na tayo mag-move on to our last question. In determining our rate of flow, given yung constant head difference na 1.2 meters, pwede na natin consider ang stratified soil sample natin as one type na lang since given na nga yung equivalent coefficient. So recalling our general formula from our fluid mechanics concepts, Q is equal to the velocity times the area, wherein our velocity is also equal to our hydraulic conductivity K multiplied by the hydraulic gradient I. Furthermore, the value of our hydraulic gradient I is equal to our head loss or constant head difference, which is yung makikita niyong distance sa figure na H, divided by the total length of the soil sample. With that, we would be able to come up with this formula. Take note lang rin, ang hydraulic gradient kasi natin is a unitless value, since ang H and L are both length measurements na dapat magka-cancel out yung units. With that said, actually mabilis na lang to from this point. Huwag na lang talaga kayo malilito sa pag-plug ng mga values. So K is equal to 0.00357955. Kung gusto niyo mapalabas yung nearest accurate value, pwede niyo rin naman siya i-store na lang sa mga calculators niyo. Then, to multiply, yung hydraulic gradient natin, which is height of 1.2 meters, divided by the total length, which is 150 plus 200 plus 100, equal to 450 millimeters. Now, keep in mind, sa mga ganitong formulas ng HDE, usually dapat laging similar ang mga pinaplug in nating units depending sa hinahanap or ina-expect nating results. But as for the hydraulic gradient, since unitless naman siya, okay lang if either gawin niyo siya both na in millimeters or in meters since magka-cancel out lang naman din dapat. So ako, I decided to write it in meters para medyo maikli lang yung solution. But for our area naman, since ang given natin na unit of length for coefficient values is in meters, galing dun sa meters per second, yung area natin na 100 millimeters by 100 millimeters ay magiging 0.1 meters by 0.1 meters na lang. And isa pa to, pag hinahanap is area ng rate of flow, ang i-consider dapat is yung sa cross-section or yung area na perpendicular sa flow ng fluid. Minsan kasi yung iba, since may given na ganitong figure, ang nakakonsider nilang value ng area is itong area ng soil na naka-reflect sa screen. So mali yun. Be mindful na lang talaga dapat sa mga ganyang parts. Moving on, plugging in this equation in our calculators, we would get an approximate value of 9.55 times 10 raised to negative 5 cubic meters per second. So, kung mapapansin nyo, iba yung unit ng final answer natin na nasa situation box for question number 2, which is in cubic meters per hour. So, to get this value, convert lang natin yung unit of seconds to hour by multiplying it with 3,600 seconds per hour. This way, maka-cancel out yung units ng seconds, and this gives us the final value of 0.3436. And that's it for this episode's situation.